Assalamualaikum guys, I am Dr. Sarfarazli. Again, our course title is Introduction to Riemannian Geometry. Course code is Math 4129. It's a 3 credit hour course. Uh, Today's topic is inverse transformation. Inverse transformation mean first question is transformation of polar plane metric into Cartesian plane metric. As we know, uh, r is equal to x square plus y square, and x is equal to r cos theta. Theta is equal to tangent inverse y over x. Y is equal to r sin theta. We are familiar with these parameters and these transformation equations. In general, x and y are Cartesian coordinates, r and theta are polar coordinates. Now, we transform these coordinates x y into x1 x2 and r theta we replace with x1 bar x2 bar. Then the above these two equations becomes mean r is equal to x square plus y square become x1 bar is equal to x1 square plus x2 square whole square root, and x second term mean theta is equal to tangent inverse y over x. So theta is replaced with x2 bar. So x2 bar is equal to tangent inverse x2 over x1. And similarly, the right hand side of this equation mean x is replaced with x1 and y is replaced with x2. So our second equation become x1 is equal to x1 bar cos x2 bar, and x2 is equal to x1 bar sin x2 bar. Mean we change we replace x with x1 and y with x2, and similarly we replace r and theta in other coordinate system. R is replaced with x1 bar and theta is replaced with x2 bar. Guys, as we know the transformation equation of any tensors, here we have a transformation equation for a metric tensor. GAB is equal to delta A bar A, delta B bar B, G A bar B bar. Here delta A bar A is equal to delta 1 bar A, delta 2 bar A, and is equal to delta 1 bar 1, delta 1 bar 2, delta 2 bar 1, delta 2 bar 2. In the same result we have for delta B bar B. This is the matrix form of a delta, and this delta is also written in the form of derivative. Delta A bar A is equal to partial x A bar over partial x A. We have proved this in a fine connection, this result. So this is the result as we have learned in previous lectures. Now we find every term delta 1 bar 1 as delta 1 bar 1 is mean this is the derivative of x1 bar with respect to x1, and since we have x1 bar is equal to x1 square plus x2 square, actually if I revise these terms, x1 bar is stand for r, and r is equal to in polar coordinates r is equal to x square plus y square whole square root. So these terms are x1 bar is equivalent to r. No, so x1 bar is equal to x1 square plus x2 square whole square root. We differentiate this term with respect to x1, and the answer is x1 over x1 square plus x2 square whole square root. Actually when we differentiate it, this is the answer. Actually if we solve this equation So we using the power law of differentiation, this result becomes x1 over x1 square plus x2 square whole square root. Similarly, we take the differential of x1 bar with respect to x2. If I revise this term, x2 is y and x1 bar is r. X1 bar is equal to x1 square plus x2 square whole square root, and x2 uh, the derivative with respect to x2, we differentiate this term, which is equivalent to x2 over x1 square plus x2 square ka square root. One thing here to be understand, this x2, it is not x square. Actually this is just a parameter, or this is just a postscript, or just like a subscript. It is x2, it is not a square. So second term, we are in third term, delta 2 bar 1. Delta 2 bar mean uh, partial x2 bar over partial x1. X2 bar is equal to theta, and as we know that theta is equal to tangent inverse y over x. Here we have changed these in parametric form. So we have x2 bar is equal to tangent inverse x2 over x1. So differentiating with respect to x1 and simplifying the result, we got minus x2 over x1 square plus x2 square. Here we simply apply the derivative of tangent inverse, and in third term, delta 2 bar 2 is equal to partial x2 bar over partial x2. Here we are taking a derivative of x2 bar with respect to x2, and again x2 bar is equal to tangent inverse x2 over x1 when it is differentiated with respect to x2. So we got the answer x1 over x1 square plus x2 square. As previously we have written, GAB is equal to delta A bar A, delta B bar B, G A bar B bar. This is the transformation equation. Actually this is inverse transformation equation. Previously, as we have written, if the term of bar on left side, then their delta terms will be interchanged or replaced, mean bar will be just like a denominator. Okay, now we take the variation of a dummy index first. On right side, A bar, B bar are the dummy index. In first step, we fix B and replace A. The variation of A and B is equal to the number of variables we have used. As this equation has two variables, being just like in Cartesian coordinate, it is x and y. If we are in polar coordinate, there are two variables r and theta. So the variation of A and B and all other numbers, mean just AB or A bar B bar, variation of all numbers will be up to 2, 1 and 2. So in first step, I kept B as a fixed, and I variate A. In first term, I change A bar with A1 bar and 1 bar plus delta 2 bar A, delta B bar B, delta G 2 bar B. Mean all other terms except A bar are fixed, and we have only used A bar as a variable. Now, in second step, we choose the variation of a second dummy index, which is B bar. For first term, delta 1 bar A, delta 1 bar B, G 1 bar 1 bar plus delta 1 bar A delta 2 bar B G1 bar 2 bar plus, no, we are in second term, the variation in second term delta 2 bar A delta 1 bar B G2 bar 1 bar plus delta 2 bar A delta 2 bar B G2 2. Okay, as we know, the Euclidean metric in plane polar coordinate is given by uh, G A bar B bar is equal to 100 R square, and if we replace here this R square with new variable which is x1 bar, so this term become G A bar B bar is equal to 100 x1 bar square. One thing more here, the first term, actually the first entry in the matrix, which is 2 by 2 matrix, first entry is 1 1, second entry is 1 2, and third entry which is 0 is 2 1, and fourth entry which is R square in this matrix is 2 2. So as on left side we consider this is a metric G A bar B bar, so our first entry which is 1, this is G11, and same row 0 is G12, and the other 0 which is in second row first entry, this is G21, mean G2 bar 1 bar is equal to 0, and fourth entry which is R square in second row of this matrix, this is G2 bar 2 bar. So if we put these GAB, the values of G11, 1 2 2 1 and 2 2 in previous equation, which is just uh, third step of this slide. So GAB is equal to delta 1 bar A delta 1 bar B, and the value of G1 bar 1 bar is given as 1. We replace G1 1 bar 1 bar with 1 plus delta 1 bar A delta 2 bar B. So here is the term G1 bar 2 bar which is given. Non-diagonal entries are 0, both non-diagonal entries are 0. So G1 bar 2 bar and G2 bar 1 bar, both terms become 0. Plus the fourth term of this equation, delta 2 bar A delta 2 bar B, and the value of G2 bar 2 bar is R square. Simplifying second and third equations, multiplying with 0 becomes 0. So we remained with first term in the equation and fourth term in the equation. First term become delta 1 bar A delta 1 bar B plus R square delta 2 bar A delta 2 bar B. This is our general formula for the solution of this equation, or this problem, or this question which is given us here. Now on right side we need every term, inverse of every term. In given equation, first term is G1 bar 1 bar, so against this equation we need its transformation G11. So on left side A and B are replaced with 1 1, both terms A and B variate 1 1, so our right side becomes delta 1 bar 1 delta 1 bar 1 plus R square delta 2 bar 1 delta 2 bar 1 is equal to first term becomes the square of delta 1 bar 1 whole square plus R square is as it is, and delta 2 bar 1 square. Now as we had found the derivatives of these terms, we found delta 1 bar 1 like x1 over x1 square plus x2 square whole square root, and this term is also in a square, so right square of the head plus we replace r square in new variables. In polar coordinates, as you know, r square is equal to x square plus y square. Now in this question we are dealing with new variables. We had replaced r and theta with x1 bar and theta x2 bar, and x and y are replaced with x1 and x2. So here the value of r square become x1 square plus x2 square into the term for delta 2 bar 1 is given as minus x2 square x2 over x1 square plus x2 square whole square root, and we have the square of whole term. Now taking the square of first term in third step, our first term become x1 square over x1 square plus x2 square, and square root is cancelled with square, plus in second term when we apply the square with square root term, our first term become x2 square over x1 square plus x2 square whole square root. So this term is cancelled, taking the LCM of both equations as the LCM of both equation is same. So this is equal to x1 square plus x2 square over x1 square plus x2 square whole square of square. So denominator and denominators are equal, it will be cancelled, and then we get answer is 1. So our first term g11 become 1. Now we need second term g12. Actually we have g 1 bar 2 bar in polar coordinates, so in Cartesian coordinate we needed g12 is equal to delta 1 bar 1 delta 1 bar 2 plus r square delta 2 bar 1 delta 2 bar 2, and substituting the values of delta 1 bar 1, which is x1 over x1 square plus x2 square whole square root dot delta 1 bar 2 is equal to x2 over x1 square plus x2 square whole square root, plus r square is replaced with the x1 square plus x2 square, and substituting the value of delta 2 bar 1, which is minus x2 over x1 square plus x2 square, and the last term delta 2 bar 2 is replaced with x1 over x1 square plus x2 bar square x2 square. Guys, all these terms we had found previously using the partial derivatives of the given terms. Now in second last step we multiply first term with second, we got x1 x2 over x1 square plus x2 square, as the denominator in both terms is same, and just square root when we multiply both terms, so square root is vanished. So we get first term x1 x2 over x1 square plus x2 square minus now we are in second term. I start from right side, x1 and x2 are multiplied, and the lower terms. Okay, guys, in this step we have missed one thing. Multiplying these terms x1 square plus x2 square, x1 square x2 square, one term is cancelled with the term of r square, so we remained with x1 x2 over x1 square plus x2 square. So first and second both terms are same, so these are cancelled, and So answer is a 0. Yes guys, we know that metric tensor is a symmetric. Symmetric mean if we replace if we interchange the index, its index, the answer will be the same. So using this property of a metric tensor, g12 is equal to 0. So similarly the answer is g21 must be a 0. So the non-diagonal entries gave answer 0. No, no, the fourth term of the metric is g22 is equal to delta 1 bar 2 delta 1 bar 2 plus r square delta 2 bar 2 delta 2 bar 2. Actually guys, we have used here in the general formula, here is a GAB, and we replace both A and B with 2. So this equation becomes delta 1 bar 2 square plus r square delta 2 bar 2 square. Now substituting the values of delta 1 bar 2 square and r square delta 2 bar 2 whole square, the second step become x2 over x1 square plus x2 square whole square plus x1. We replace the value of r square, which is x1 square plus x2 square into the second term delta 2 bar 2 is x1 over x1 square plus x2 square whole square. So our first term becomes x2 whole square over x1 square plus x2 square. The square root is cancelled with square plus this term is cancelled with 1 square, as we have square of the denominator. The first term is one term is cancelled with the denominator, so we get x1 square over x1 square plus x2 square. So we get taking LCM of both terms, we get x1 square plus x2 square over x1 square plus x2 square. So denominator is equal to numerator. This must be cancelled, and we get answer is 1. Okay, in this using these techniques, we have found all the terms required for a metric GAB. So as we need G11, G12, G21, G22. Guys, you know G11 is termed as 1, and non-diagonal entries G12 and 21 become 0, and we got the fourth term is also 1. So guys, in this style, in these techniques, we got the inverse of the metric tensor. Okay, it's the end of this equation, this question. I hope you understand this.